Lawrence Krauss is a world-renowned theoretical physicist, a man who significantly changed our view and our understanding of the cosmos. He's a fierce advocate for the public understanding of science and aims to bring it closer to the masses through the Origins podcast. Recently, he's also been pushing for much-needed societal and cultural changes. Lawrence's books have been pivotal in popularizing science and have profoundly impacted me since I first read them. And his latest book is no exception. Check out my episode from earlier this year, right here. Join us as we embark on a captivating journey to the edge of knowledge, recorded live in October 2023 at the San Diego Air and Space Museum.
So this is actually from an 11-year-old who asked a good question. Are any of the meteorites you handed out radioactive? And do you have any thoughts about that?
So meteorite radioactivity. Well, what's interesting about it is that they were sort of formed thanks to a nuclear processes, a radioactive process. Well, not radioactive, but nuclear processes. Now, when a star of a certain size, a certain girth, gets to the end of its lifetime, it no longer can support its massive body that it's built up over billions of years. And something called a type 2 supernova occurs, where the material that makes up the outer layers no longer is supported by the pressure. The weight of that outer material is no longer supported by the heat pressure, keeping the nuclear fires going. And that happens when it makes iron. When the star fuses two lighter nuclei together to make iron, silicon, or silicon oxygen, you make iron 56, and that is no longer exothermic, doesn't give off energy, and then the star collapses and then explodes back in the most luminous explosions since the Big Bang, and these could be seen from across the entire universe, essentially. So this material is billions of years old because it's the material that was made the last thing the star ever did. It's like, what's the last thing that goes through a fly's eye before it dies on your windshield? It's butt. Get it? Okay. Anyway, this material is mostly iron, so it's not radioactive, and it is a pristine material that shares something in common with your blood, because the iron in your blood came from the same supernova process that produced these iron meteorites. So this stuff is magnetic, it is not radioactive, and you should play around with it if you're so inclined, and you will not get endangered. My word is I'm a doctor also.
So, well, let me make a slight correction there. Everything is radioactive, and I think, and so there's radioactivity coming from your big toe. Small amounts of it, trace amounts of radioactivity everywhere. One of the big problems in making particle physics new experiments to look at things like dark matter is to get rid of the radioactivity. It's really hard because we're looking for events that are so rare that if there's a little bit of radioactivity in this big tank, then it'll overwhelm the thing we're looking for. So even if, and I think a book I wrote, again, well, in fact, we were looking for things in dark matter detectors. We're looking for events that are about 1 million times smaller in rate than the radioactivity in your big toe. And so there's a little bit of radioactivity in everything, and that's okay. Even if it's just impurities. It depends on things, and so, and there's also stuff coming from up there, cosmic rays. So I have a little Geiger counter I like to take with me around places to see when I was up in Greenland looking and stuff. But anyway, so there's a little bit of radioactivity, but nothing. But this is iron, which in general is not a radioactive. The dominant stuff here is iron, which is the most stable. In some ways, the most stable of the heavy elements at all. Okay. This one we can both answer too, I think. Maybe I'll start. Brendan asks, if aliens were to exist, how much more intelligent than us would they be? Or could they reach us even with less intelligence? The answer to the first question is we don't know. We have no idea if they exist, whether they're more intelligent or less intelligent or intelligent. If they're far less intelligent, we have much less likelihood of finding out about them, because the way that other aliens would find out about us, and why most of the universe doesn't know we exist, is they'd look for the radio transmissions that we've emitted, and we've only been doing that for 150 years, and that means since it traveled the speed of light, if you're more than 150 light years away from us, which is most of the galaxy, there's nothing special about the Earth. So we might learn about other kinds of life, but intelligent life would require to be at least technological, at least as technological as us. Now, one might say, and I'm going to only talk a little bit because you can add, one of the things we'd say is, look, our sun is only 4.5 billion years old. Our Earth is 4.5 billion years old, our solar system. And the galaxy is about 12 billion years old. So you might say that most stars are a lot older than our sun, and a lot of them are. And therefore, civilizations could be billions of years older than us. And that's true, maybe. But the problem is, in order to have the iron that Brian was just talking about, stars have to explode. In order to have all the materials that make up the Earth, stars had to explode, and it takes time. And so in the early history of our galaxy, there weren't many heavy elements that would make up rocky planets. It takes time. You can argue that most of the atoms in your body went through maybe 10 different stellar explosions before the one that may have produced us now. And that takes time. So it could be that there aren't many more civilizations that are, as old as us, because it took 4 billion years for intelligence to arise on Earth. And so but the neat thing is we don't know. And in a situation like that, the only way to find out is to look and let the universe tell us. And if we don't, as Carl Sagan would say, absence of evidence is not evidence of absence. It just means you have to build a better experiment. And Brian knows all about that. Not seeing something often means you just have to do a better job. And technology improves at a great rate, so you can. Anyway, you can add to that.
Yeah, I mean, I would just say if you plotted the history of the universe, if you plotted intelligence, even on Earth, there was a long, maybe dominant portion of Earth's history when dolphins were more intelligent than the Denisovans and Australopithecus and all sorts of other things, or their predecessors maybe, because they've been around longer than human beings or Homo sapien have been around for. So the question is not maybe more or less intelligent, but technological. Because no matter what, the dolphins can keep evolving, but you're not going to build a Falcon Heavy underwater. You're not going to do Mellards. You're not going to have technology without the opposable thumbs that we have. So they may be even more intelligent things than us in the universe, although there's zero evidence for that right now. I think that's the best thing we can say. We don't know, but these things that manipulate space and time to get here, they are subject to the fundamental laws of physics, thermodynamics, etc., which we have great confidence will never be overturned. But I think there is a fallacy that because there's so many stars out there, you and I have talked about this, there has to be life. And I told you, and you've been to Antarctica or Canada, I don't know which one is colder. You're from Canada, but I've been there. There's very little life there. So if you were to sell,
there's a lot of extreme. What we've learned is there's life in extreme environments you'd never imagine there'd be life in acid, in boiling water, and cold. Life seems to be able to fill every niche that's possible. So, in fact, I suspect strongly, now this is an intelligent life, that there's microbial life elsewhere in our solar system. I would be surprised if underneath the oceans of Europa or Enceladus we didn't find evidence of microbial life, and it would be very fascinating, and we could talk about that. But we don't have time.
See if he's right in 5 more years.
But
go ahead.
Yeah, we'll find it. I will say, as a pessimist, which I am in general, my late friend, who's a writer named Cormac McCarthy, was wrote very dark books that some of you may have read or seen movies based on his work. And when I first met him, he was a very cheerful guy, and I asked him how he could be so cheerful, and he said, "I'm a pessimist, but that's no reason to be gloomy." Anyway. This is a quick question, but I have to answer because it comes from a 9-year-old who I know, Arnie, and it said, "How did you know that the card I was thinking of was the 6 of spades?" And the answer is, I tricked you. Okay. Angela asks, this is probably a question for me, but is dark energy potential energy or kinetic energy? If it's one of the two, how is it measured? That's a really good question. Energy, if you took high school physics, energy comes in a bunch of different forms. One form is the energy of motion. If I throw a ball at you and it hits you, it's got energy and it can do work on you, knock you over. That comes from kinetic energy. If I lift the ball up in the air, it's got the potential to do work. If I let it go by falling on you, that's potential energy. And if you were going to say that dark energy is more potential energy, it's not due to motion. In fact, there's nothing to move. That's the weird thing. It's the energy of empty space, so there's nothing there to move. So it's potential energy. But how it's measured, Well, there are different ways, and we're looking, and one of the things, Simons might do may help on that. The way it was first discovered was the fact that dark energy, as I said, is gravitationally repulsive, and it causes the universe to expand ever faster. And by looking at distant objects and seeing how fast they're moving away from us, as a function of their distance, and therefore the time we look back in the history of the universe, because it takes light finite time to get to us, we can map out the expansion rate of the universe and discover, to the surprise of the observers, that the universe is speeding up. And the amount by which it speeds up is directly related to the amount of dark energy there is. And that's the first way to measure it. There are other ways, and one of the other ways is to, again, always looking at the history of the universe, kind of doing universal archaeology, which is really kind of what Brian does, is to look at state by state and try and look at how individual objects are evolving, like galaxies, and all of those things depend on the expansion rate of the universe. So lots of different measurements are trying to be performed to see if that dark energy is really constant, which I'm convinced it is, but we'll need experiments to see. Do you want to add anything into that? Okay. Here's one we could both talk about, anyway, I'm not sure we have much to say, but how advanced is AI versus what is used by the public? I think you're meaning how advanced are there secret AIs that are much more advanced than they're used by the public? I actually don't think so. Because the AI systems are really produced by companies that are hoping to make money. And so they require a lot of money, and they have to use the publicly available information. They mine the internet to try and figure out, to predict what the next word you're going to say is, or the next word they should say to you. That's all they do, is they just try and predict the probability of the next word. At least the AI that most of you are familiar with, ChatGPT. And it's pretty basic, although it's quite amazing what it can do. And in fact, I don't know what, it's okay to say it. Brian, when I talked to him earlier by email about what he was going to ask me, he asked ChatGPT the questions he should ask me. And I said I didn't think they were as good as the questions we could come up with, but they're still pretty good.
Yeah, on my website, I made a Brian bot. I took all of my books, all of my podcasts, transcripts, solo episodes with you, me, Joe Rogan, and I put it all into there. And now I no longer have to tell my kids bedtime stories. So I would go home, check in a few minutes. No, but one thing that they are doing that we don't really do, we meaning normal people, coders and people actually doing sophisticated, software engineering, computer science, so forth. They are using, they are extracting more information, I think, than I do when I ask it, what are the, top 10 reasons that you should become a cosmologist or so forth, or the questions to ask renowned physicist Lawrence Krauss. I find it very enjoyable. I think it's really fun and useful, but I'm worried that they're actually going to get dumber with time, and it's a phenomenon we observe in high-performance computing. The better the computers get due to Moore's law, the more people want to use those really powerful computers, and that saps their efficiency at putting out new data analysis, new papers, and so forth. What's happening with AI until just a week or two ago, ChatGPT wasn't trained on the internet before 2021. And I always seemed, why not 2021? And that's when GPT-1 came out. So now they're actually training, these are crawling the web, and they're processing things written by AIs. And that's kind of going to bring up maybe kind of like what happened with mad cow disease, except mad bot disease. They're going to start to really get kind of hallucinogenic, and it could be reduce their efficacy. So we'll see what happens.
Yeah, and I will say to promote, I'm not sure when it's going to come out, but I recorded a really fascinating episode with one of the most remarkable computer scientists I know, a theoretical computer scientist named Scott Aronson. And he's now got interested in AI safety and doing some really neat things. And we talked about it. So it'll come out in the next month or two. He's a really neat guy, really deep, a very deep thinker. I'm very impressed with him.
I have a special favor to ask you. YouTube Analytics tells me that of the 30,000 plus of you that viewed my previous chat with Lawrence for his book, The Edge of Knowledge, only 1/3 of the viewers actually subscribe to the channel. I'd really appreciate it if you'd consider subscribing to this channel. Doing so helps me get great guests and helps me deliver the great content that you've come to expect from this channel. Thanks so much for helping me help you. Now back to my live chat with Lawrence Krauss.
Kim says, I read somewhere that quantum entanglement could be key to teleportation. What are your thoughts on that? Do you see this becoming a reality? Has it already and I just missed it? That's kind of a Star Trek question. I remember when I first heard about quantum teleportation. I mean, it was brilliant. It was brilliant marketing of the physicists who did it, because every journalist in the world would then, well, a lot of the time called me because of the Star Trek book. But the quantum teleportation and teleportation are two very different things. In fact, the fact that we can do quantum teleportation is the very same reason that we can't do people teleportation. Okay, quantum mechanical systems are very, very special. It takes a lot of work to observe quantum mechanical properties. You have to very carefully prepare systems, very, very carefully. Experimentalists have to do a lot of work, which is why they won the Nobel Prize last year for the work they're doing to isolate the quantum properties, the weird quantum properties of quantum systems. And they're weird because we don't see them. And one of the reasons we don't see them is we're not isolated systems. I'm interacting with you and the light in this room and all the particles in my body are interacting. We are the worst possible. We're not in a nice, simple quantum mechanical state. So for certain very simple quantum mechanical systems, we can do something that looks like teleportation. Like we measure the properties of a particle here. It instantaneously affects the properties that you will measure of a particle over there. It sounds like information is being processed faster than light. That's not true. It just happens. There's no message you could ever send from here to there that would be faster than light. But it's only possible because it's a very, very carefully prepared system, and you don't allow it to interact with the environment all the way in between. And so we are not carefully prepared quantum mechanical systems. So we are not going to be teleported, and it's not going to happen. And as much as I'd like it to happen, and especially as I'm on planes a lot, I love to be able to be teleported, but it's not going to happen. Do you have anything else to say about that?
No, just that we wouldn't know if you were actually from the future teleporting back in the past just to play a trick on Kim, which we pre-prepared that quantum question. No, I'm just kidding. Nothing else to add. Let's see the next one.
Okay, I'm not going to talk about time travel. I did the other day. So this is one I think you can, well, we'll both answer, but I think you could probably address it interestingly enough, given you just mentioned the Simons thing is $100 million. It happens to be funded by individuals, but as well as the government. But anyway, the question is, how should one respond to inquiries about why the public should fund costly physics experiments?
Well, I mean, I think one statistic that, GPT told me, and I assume it's true, is that the budget for NASA is less than what you ladies and maybe a few gentlemen spend on lipstick every year. It's a very small portion. And people are confused by that because they see all the great things NASA does. Look at the moon, we've been on there. There's other NASA things, the Apollo thing that you guys were in for the VIP earlier. So it seems like this huge, they must be costing a tremendous amount. It's actually quite small. And increasingly, more and more are private individuals and foundations coming up with large shares of it that then become partners with the government to reduce the government's risk, but take advantage of the agility of a private foundation and the risk, tolerance that they might have compared to a government panel where we literally will have, 30 people reviewing it for 10 or 15 years, and rightfully so. But I guess the main thing that scientists could do is share their, the one place that we differ maybe is that I believe that we actually should require some amount of training, outreach, how to communicate with the public, both for the benefit of the public who will learn more about science, but for science itself. Because if science cloisters themselves, we cloister ourselves in our ivory towers, doing special things with specialized people and specialized tools, the public, you guys are going to lose interest and say, what the hell? I mean, if I used to work in a kitchen, in a American restaurant, style restaurant in New York State. And if my boss came in, he said, what are you doing? I said, listen, boss, you can't understand what I'm doing. What I'm doing is so specialized, so intense, so intelligent. They would say, you're out of here. We don't need you anymore. You're arrogant. And I think science as a whole does this. And the excuse is always, I'm not good at it. Well, I'm sorry, Lawrence, but you weren't born knowing quantum electrodynamics. You had to learn that from your teacher Feynman and from other people. You put effort into things that you deem worthy and valuable. And I think we need to teach students at a young age. There are college students and high school students here. Make a YouTube video, do something. It'll redound to your benefit in ways your future self will thank you, public will thank you, science will thank you.
Well, I don't disagree with you. in the way you think, because I don't think they should be required, but I think what we need to do is include communication in the training of scientists more, and for many reasons, not least. First of all, most students who are taking classes in science aren't going to become scientists. But, I spent a lot of time when I at Case, which is largely an engineering school, talking to engineers. And the engineers who succeeded are the ones who could communicate best in their company. And so I was once, many years ago, MIT asked me to be on an advisory board. And interestingly enough, the idea was to include writing in the science courses, because at MIT, they all had to take a writing class. But it was from some writing instructor that none of them had any respect for. But if the professors that they had respect for required them to write in the class, then they'd spend time doing it. And I think you're right. It's a skill that's important for anyone. And if we train more students to do it. In fact, when I was a graduate student, I never once, I was amazed. All the time I was a graduate student doing my PhD at MIT, never once was asked to give a presentation. The first one I gave was after I got the job at Harvard and I was down at Princeton. It was really amazing to me. So I think it would be a good thing. But regarding the cost, I do want to take a little time, because they don't cost much. That's the point. $100 million is in the scheme of things is not much. Even $10 billion, the Large Hadron Collider or the Hubble Space Telescope, spent over 20 years, is less than the cost of a sophisticated, certainly much less than the cost of an aircraft carrier. It's like the Xerox costs of the Defense Department maybe are 10 times as big. And so it's really not much. And therefore you have to ask yourself, are we so poor as a society that we can't do that? And my favorite line of this comes from Robert Wilson, who was the first director of the Fermi National Accelerator Laboratory. And when it was being built, he testified before Congress. And they asked him if it would aid in the defense of the nation. And he said, no, but it'll help keep the nation worth defending. And I think that's really important, because if we are so poor that we have to stop asking questions about the universe, which is one of the driving things that keeps humans human, then we might as well just give up. Anyway, okay. Mario asks, for both gentlemen, what is your opinion on how the government is handling the UFO situation? Do you believe the videos are solid proof? I'll start. No, videos are not solid proof. I can give you videos. Every movie is not, watch a good movie and you'll see you're being tricked. You got to watch out about being tricked. Okay. And magic I like because it's honest lying, because I'm telling you I'm tricking you. But so videos and eyewitness evidence is the worst kind of evidence. Unfortunately, they use it in court cases, but it's not good evidence, and you have to be skeptical. So that there's not a single piece of evidence, not one piece of evidence. I repeat that. There's not a single piece of evidence that anything that we don't know what we see. And there are lots of things we don't know what we see. There's not a single piece of evidence that the scientific community would say is solid of anything related to aliens. Okay. And that's, no matter what people say, there's no evidence about that. As far as the government's handling it, I actually think they're not doing as bad a job now. They're trying to be more open. And I watched the press conference from the NASA committee that talked about it, and I think they buried the lead, as we say in the newspaper business, because it was late in the thing where they said there's no evidence of aliens. There was a long preamble, and most people didn't get it. But the idea is to try and be open about it. But the notion to me, the most unrealistic thing about aliens and UFOs is the idea that our government could have this incredible conspiracy of secrecy for 60 years. I mean, come on. Nothing can be secret. And just think about it. If one person who had knowledge about this could make $1 gazillion if they could speak about it, when that's the case, there's no way that's going to remain secret. So to me, the most unrealistic thing about all of this UFO conspiracy is that the government can keep secrets.
Yeah, I mean, I would only add that, the two of us up here and the other scientists that are here tonight represent incredibly conflicted people, in that there's no one more than us, we scientists, who would love nothing more than to discover the existence of an advanced civilization that mastered the laws of time travel, of physics, and interplanetary wormholes, correlations, whatever, and able to do these feats of technology simply because of the venal reason that we would get to have thousands of Nobel Prizes, that we would get to skip ahead in our understanding of science by many centuries. And so I kind of get a little bit annoyed when my friends in the UFO pro community say things like, oh, you're just covering up, or you have a vested interest in us not being correct. And big astronomy, and I love it if big astronomy could control anything, even for self-interested reasons. So anyway, we have a vested interest, and we are saying we haven't seen this. We would like nothing more than it to be true. But as Lawrence's friend Carl Sagan used to say, you need to keep an open mind, but not so open that your brains fall out. And you have to hold them to the same standards, our friends in the UFO community. Just because you can, see things that eyewitness reports, like Lawrence said, it's really not rising to the level of data analysis and stuff. So I largely agree. But just to add, I would love it to be true. I want to have evidence. I say I don't want to believe, as Mueller.
Fox Mulder said, we want to believe.
I want to have.
We all do want to. Yeah, well, and the problem is most of us do want to believe. And that what scientists have to remind themselves is that they want to believe in their own experiments, in their own theories. And what science is good at telling us is that recognize that you want to believe. And as Feynman said, the easiest person to fool is yourself, because you know what you want your theory to be right. You want your observation to be right. You constantly have to second guess yourself. And that's really something that's a lesson from science that we really, can be so important.
One last thing. So there are people in science even. I've interviewed them. Steve Koonin was on my podcast. So Lawrence has written a book. Steve Koonin wrote kind of an opposition book that, unsettled science. I just want to say that all of us agree, even if you're a climate change skeptic, that reducing CO2 and the concomitant pollutants will redound to the benefit of human health. I don't think anybody, even the most ardent, opponent of climate change regulation or technology, will argue against that. But just the same way with UFO technology and supposed technology, I think it could also benefit humanity by making aerospace safer, by having better communication, freedom of information, and transparency with the government. I think that's always a good thing. So I think no matter what, it's a net good. But again, let's keep scientifically approaching it, and I think that will eventually redound to the benefit of everybody.
And I won't, because of time, I won't say, but if you, Carl Sagan's last book, Science is a Candle in the Dark, is a masterpiece. And it's wonderful to have him read him talk about UFOs, because he points out what a cultural phenomenon it is. People used to see the same things 100 years ago and call them fairies. I mean, it's a property of the culture at the time. And so why were UFOs being seen 500 years ago? Because they were attributed to something else. So each culture of its time has their own version of UFOs. And, just like the fact that most people who believe in God happen to believe the God that their parents believe in should make you suspicious. You should also be suspicious of the fact that these things are a property of time. And I wanted the last question because I want you to get home to your kids. And it's a simple question. What's your favorite thing or topic to talk or BS about? Doesn't have to be science related. And why is it so fascinating or enjoyable to you?
Well, living here in San Diego, the thing that I turn to for relaxation are the San Diego Padres. And I always say, easiest job in the world is to be a meteorologist here in San Diego. This is typical weather for us. And the hardest job is to be a sports chemist, because we've never won a single championship. So for me, it's relaxation is that. I get a lot of enjoyment sitting on the couch with my kids and my wife and just watching the Padres lose.
The rest of us enjoy watching the Padres lose too, but I think for me, I would say it's movies. Things I see, and I don't really watch TV, so for it's movies or documentaries, but BSing about movies I like, and I make some movies too, and so I've always been fascinated by movies, because they also inspire the imagination. And in fact, as Stephen Hawking wrote in the foreword of the Physics of Star Trek, science fiction helps inspire our imagination, and so anything that helps inspire our imagination excites me, and I get the same excitement from movies as science, because they both tickle my mind. Thank you very much.
Thank you.